To demonstrate this buffer overflow concept, I put together this very simple C program, and I'm going to go over the program with you just to let you know what the program does. So first I create this container or buffer to store a user input, in this case a password. So I have a space for 8 characters I set aside in the memory to store a user input, and the user input goes into this container or buffer named as password or PASSWD, and I have this variable whose name is auth flag. So basically this is a variable or flag I use to remember whether the user is granted access or not. So I'll set the value of this flag to 1 if the given password by a user matches the password I'm expecting. But by default, this flag is set to 0 unless the password given to the system matches the password the system is expecting. The flag value remains the same, in this case 0. So what happens is I first print the message, type your password, and the user supplies the message, and this getAs command is used to read the user input typed by the user, and the password typed by the user is going to be stored in that buffer I created earlier. So the buffer is called PASSWD, so that's what this is. And then I'm going to be comparing the user supplied input stored in the password buffer with the password string I have hard-coded in the system. So I'll be comparing what's given by the user and what is stored in the system. In this case, the secret password is really password, PASSWORD. So if these two values match, I'm going to be displaying a message that says authentication success, and if they don't match, and then I'll display a message authentication failure. So as you can see, strcmp, this command returns 1 if the two values don't match, and then if they match, it returns 0. So that's why it's set up this way. And then if the password matches, I'm also going to set this authentication flag or auth flag value to 1, because now I know the user is a valid user and I'm going to be granting access to my resources. So that's why I set it to 1. And based on this auth flag value, if this is 1, if it's true, then I'm going to be granting access. So I'm going to print this message, granting access. And then if the auth value is not changing, because if the values are not matching, only this part of the if statement is going to be executed, and then the auth flag value will remain 0. So then this message will be displayed, denying access, because the auth value is never changed. Next is compiling the source code we just reviewed. We use a Linux compiler called GCC to compile our source code, and we use a special option here, -f, no stack protector. We use this because unless I have this here in place, when I try to run the program and try to overflow its buffer, the operating system will keep me from doing it. Next, I use another option, -g, GDB, and what this does is when I use a debugger called GDB to do my demonstration later, this option will allow me to somehow recognize each line of the source code and refer to them by their line numbers. And then the next is simply the name of the source code file, and then -o specifies the target file name, meaning when the compilation's done, what's going to be the name of the executable file. So in this case, the executable file, the name is buffer test2. So now I'm ready to compile the source code So I just press enter, and as you can see, the compiler is complaining about getAs because it is a dangerous function to use, and it says it's deprecated. Now we're ready to run our program, but I'm going to be running this in a debugger called GDB because that way I can show you some changes in the variables, and that way I can control things better. So to run this program in a debugger, I'll just type the name of the debugger in this case, which is GDB, and then the name of the executable, which is buffer test2, and then press enter. So now I'm inside the debugger. The next step is to put some breakpoints so that I can make some controlled stops when I'm executing my program. So I'm going to be using 3 breakpoints, but before I set the breakpoints, I'm going to show you the code inside the debugger. To do that, I use the command list. So just type list, L-I-S-T, in this case, I'm particularly interested in the changes in the value of the alt flag variable. So that's why I'm going to be setting a breakpoint right there just to check what the current value of alt flag. So I'll say B and the line number, which is 7. So the line number recognized by the debugger. I set 2 more breakpoints after this one just to see what happens after this getAs function is executed, because this is where the buffer overflow could occur. If it doesn't happen, it wouldn't affect, for example, the alt flag variable, but if the buffer overflow occurs, then the alt flag variable will be affected by that. Basically, the value of the alt flag may be contaminated by the buffer overflow. So I set another breakpoint at line number 11, as you can see here. So what this does is, at line number 11, it's before in the program we try to do anything to that alt flag variable, because it actually happens at line number 19. So in this case, what happens is, if the password is something we expect and we want to grant access to the resources the user is seeking, and we intentionally change the value of alt flag here, but until this time the value of alt flag shouldn't be changing. And then finally, just before the program is done executing, I'm going to be setting another flag, so which is line number 31, just before return 0 statement, as you can see right there. So B31,